Hello, my name is Nathan Starkel, and this is Connor and I's implementation of Lab 4 for networks. So as you can see, we have all of our files open up here in the PyCharm IDE. I'm going to go ahead and run simulation 1 to showcase that our routing tables are no longer mere data dictionaries, but are now much more visually appealing two-dimensional arrays. So as you can see, we have the routing table for router A and router B, and they are orientated in the fact that the interface number for those routers, interface 0 and interface 1, make up the left axis of the table, and then the upper axis of the table represents the hosts. So essentially, 1 is host 1 and 2 is host 2. So essentially, for example, if we wanted to send a packet out interface 0 to host 1, it would have a total cost of 1. So that takes care of question 1. And question 2, in terms of updating, as you can see, router B can reach host 2 at the cost of 3, and router A can reach host B at the cost of 1. So knowing this information and having the proper update functionality present within our network, we are able to update the value of router A's interface 1, which is connected to B, and we are able to add those two values together to show that router A through interface 1 can reach host 2 at the cost of 4. So this showcases that we have the ability to update our routing tables. And then in terms of question 3, with the reply that we have to add to our implementation, we can see that host 1 receives the server reply right here, and that as soon as host 2 receives the initial sample client data, it immediately sends the server reply, and it only does this once it receives a full packet. So this implementation can be seen here in our network file in our UDT receive. And as you can see with the address, if it's a full packet and the destination address was host 2, then essentially send a UDT reply to host 1. So this ensures that a full packet is received before a server reply is sent. So now we're going to go ahead and step on over to our second part of our project, and as we can see, we have set up our simulation to have the following network topology present within the current project. And the task that was given to us was to ensure that data that goes from host 1 to host 3 follows a different path than data that goes from host 3 to host 1. So as you can see here, after this run of the program initializes, we can see that the packet is received. So essentially, router A sends router A. Okay, there we go. Sorry, I lost for a second. Router A forwards the packet through interface 0 to interface 1, which is then forwarded to router C, and router C then sends it off to router D. So as we can see, the data that goes from host 1 follows A, C, D, and then host 3 receives the packet. So going backwards, essentially when host 3 sends its server reply, it goes host 3, and then it goes to router D, and then it goes to router B due to the routing tables, and then it goes to router A, and then finally host 1 receives the server reply. So as you can see, the packets that are initially sent over to host 3 follow a different path from the reply packets that are sent from host 3 to host 1. So we appreciate you for watching and hope you have a good day. Thank you.